have studied pressure and how it changes as we move through a fluid. So let's use this lesson to learn how pressure is measured using different equipment and the new formula called the manometer equation. So the first one we study is called the barometer. Its basic function is to measure the pressure of the atmosphere. So we've already talked about atmospheric pressure and how it works. Now, how does the barometer operate? So we first fill a tube with mercury, and the tube is inverted into a container that is also filled with mercury. Then the natural thing that is supposed to happen is that the mercury inside the tube would like to rush out of the tube and into the container, just like turning water in a bottle upside down. However, atmospheric pressure would like to push down on the mercury in the container because it is an open container which is being affected by the atmosphere. At the point, the fight between the mercury in the tube and the atmosphere for who will win the push will end, such that there will be a balance. This balance is as a result of the pressure in the tube being equal to the pressure of the atmosphere. Now let's not forget that in the same liquid, the pressure at the same horizontal level is the same. So let's label 2 points in this container and the tube. Then using Z1 as a reference point, we can say that P2 plus gamma Z2 equals P1 plus gamma Z1. Once Z1 is the reference point, which is 0, we can cross that part of the equation out and then solve for P2. P1 at the top of the mercury in the tube will just be equal to its vapor pressure, which is a very small value that we can ignore. And then we can say P2 equals minus gamma Z2. Once you have been able to establish this, P2 at that level is the same as atmospheric pressure. So you can say P atmosphere equals minus gamma of mercury times the height of mercury from Z1. And if this experiment is done well at sea level, it always yields a value of 760 millimeters of mercury. So sometimes the pressure of the atmosphere is referred to as 760 millimeters of mercury. So 1 atmosphere equals 760 millimeters of mercury. Then let's look at the next pressure measuring device called the piezometer. So the piezometer is just a transparent vertical tube that is placed on top of pipes when fluids flow through them. So let's look at it in this way. When you have a pipe that is burst, the water that rushes out is directly proportional to the amount of pressure inside the pipe. So the piezometer is used to see the rise of the liquid, and we can use that to calculate the pressure in the pipe, so that the difference in the height of the liquid that is rising from the tube, that is rising in the tube, will just be proportional to the pressure in the pipe where we have the flowing fluid. However, there are disadvantages to the piezometer. The first one is that it cannot be used to measure the pressure of gases easily, because gases will just rush out of the tube and escape. Also, if you are using it to measure pressure of liquids and the pressure in the flowing liquid is too high, then it will overflow and then we can't measure any pressure at all. Now let's go on to look at the YouTube manometer. So this one operates on the idea that some liquids are heavier than others. And if it is so, then smaller heights of some liquids will balance higher heights of other liquids. So for example, 3 meters of water is proportional to 0.22 meters of mercury, which means that mercury is far heavier compared to water. So here we learn a new formula called the manometer equation. It says that P2 equals P1 plus the specific weight times the height of any liquid when we go down minus the specific weight times the height of any liquid when we go up. In the equation, P2 is the unknown value or the unknown pressure. P1 is a known pressure where we can start from. So the simple explanation to this equation is that if there is a pressure that we don't know, start from a known pressure and then move through the tubes or the channels, such that if I move from the known pressure and I go down, then I will add up the pressure because I know pressure increases as we go down. If I move up, I'll subtract the pressure because we know or we have studied that pressure reduces as we go up a fluid. So we will understand this formula more when we start solving questions in the next session. Let's move on to what we call the differential manometer, which is used to measure what we call the pressure head, or the difference in pressure at different heights in the same tube, especially when the tube is tilted. So this is an example of the differential manometer. Let's move from P1 to P2 using our new equation. So starting from P1, we move down in liquid A through a distance of dy, so that is positive. Then we move down again in liquid A, which has a distance of dh. That is also positive. So down is positive, up is negative. Then from there we move up in liquid B through a distance of dh, and then we move up in liquid A through a distance of dy, and then up in liquid A through a distance of z2 minus z1. So the formula says that P2 equals P1 plus gamma I HI when we are going down, minus gamma I HI when we are going up. Then after expanding and simplifying, we'll have P2 equals P1 plus delta H into brackets gamma A minus gamma B minus gamma A Z2 plus gamma A Z1. Then what we do next is to group like terms, so that we'll have P2 plus gamma A Z2 on one side equals P1 plus gamma A Z1 plus delta H into brackets gamma A minus gamma B. Then we divide through by gamma A. All terms on the left hand side of the equation are in meters or in height, so we can replace the 2's by h2 and the 1's by h1. Then finally our formula becomes H2 minus H1 equals delta H into bracket 1 minus gamma B over gamma A. So anytime we are asked to calculate the piezometric head of a differential manometer, then we are just looking for H2 minus H1, which is equal to delta H into bracket 1 minus gamma B over gamma A. Then let's look at the next one, which is called the Bourdon tube gauge. So this is something that some of us have encountered before. This gauge is calibrated to measure gauge values only. Some are actually calibrated to measure absolute values, but most times they are calibrated to measure gauge values. So how does it operate? When it is attached to any fluid that has pressure in it, the pressure in the fluid rushes up the stalk of the Bourdon tube gauge, and this pushes the mechanism in the gauge to move the pointer in accordance to the amount of pressure. And the last one that we talk about today is the pressure transducer. So this one uses sensors to convert the pressure in the fluid into digital numbers that we can see on a screen.